Good, excuse me. Excuse me. Good morning. Chapter 10, Lesson 6 is on page 453 and 454. We're going to be solving rational equations, which means we're going to be having equations, not just expressions. There are going to be equal signs involved. So let's start off with something simple like number 11. 5 over x is equal to 6 over x minus 1/3. I think we're going to be able to figure out pretty quickly that our least common multiple for this has to be 3x. So we've got to have the denominators all be exactly the same. So we have 5 over x is equal to 6 over x minus 1 over 3. And we're going to have to be multiplying this stuff by something. We need to multiply this one by 3 over 3. We need to multiply this one by 3 over 3. And we need to multiply this term by x over x. That gives us our least common multiples of 3x, 3x, and 3x. Remember, we talked about the shortcut in class. When we have an equal sign in an equation, that didn't sound right, and we have the denominator all being exactly the same, we can make the denominator disappear. So this becomes 15 is equal to 18 minus x, and x becomes equal to 18 minus 15, or x turns out to be 3. Our solution. Remember the trick, when we have an equation and the denominators are all the same, we can wipe them out. What we're really doing is multiplying both sides by 3x over 1. 3x over 1, and you'll see that the x's and the 3's cancel out. Okay? So, number 11. Try something a little bit more involved, number 41. Oh my god, this looks ugly just as it is. 14x minus 2 in the numerator divided by x minus 3 is equal to 9x plus 8 in the numerator and a negative 2 in the denominator. This turns out to be nothing more than a ratio. And with the ratios, we did crisscross applesauce, and we can do exactly the same thing, a proportion. This is a proportion, and I think with an equal sign, they call it a ratio. I use the two words interchangeably. So let's crisscross applesauce. We have minus 2 times 14x minus 2 is equal to x minus 3 times 9x plus 8. We end up with minus 28x plus 4. That turns out to be, when we do the foiling, we have 9x squared plus 8x minus 27x minus 24. And what we want to do is we want to set all this to 0 because we have an equality. So we're going to do that kind of in one step by adding 28x to both sides and subtracting 4. Okay, so just kind of keep that in mind. So we end up with 0 equals 9x squared plus 8x minus 27x plus 28x, we added it from the other side, minus 24 minus 4. And if we simplify all this, we end up with 0 turns out to be 9x squared plus 9x minus 28. So we end up with A, B, and C. So we have A is equal to 9, B is equal to 9, and C turns out to be equal to negative 28. So we're going to have to use our factoring skills to come up with the factors for 9x squared plus 9x minus 28. We end up with AC minus 252 and B being a positive 9. And our terms turn out to be 21 and a minus 12. So we've got a 21x and a minus 12x that we're going to have to place. In our box we have 9x squared. We have minus 28, we have minus 12x, and we have 21x. So we placed everything in the box. 9x squared and minus 12x, they have in common a 3x, which gives us a 3x, which gives us a minus 4, which gives us a plus 7, and our final check of plus 7 times a minus 4 gives us that negative 28 area that we need. So our factors turn out to be 3x minus 4 times 3x plus 7 turn out to be 0. And the only way we can do that is with our zero product property. So 3x minus 4 better be 0. Or 3x plus 7 better be equal to 0. So x turns out to be on this side 4 over 3. Or x turns out to be equal to negative 7/3. So we had two possible answers for number 41, as we should, given the fact that this is a quadratic equation. Thanks so much. We'll see you all tomorrow.